Hello and welcome to this video on dividing rational expressions. That's dividing fractions, where a rational expression, as hopefully you recall, is an expression where there's a numerator and denominator that are both polynomials. Okay, so let's get into several examples here. My first one has to find the quotient. Now the quotient is a fancy term for the result of division. Do a little refresher course here off to the side. When you take two numbers of any kind and divide them, right, you see this division symbol. So for instance, if I took 2/3 and then divided that 2/3 by 7/9, the number before the main division symbol has a special name. The 2/3 here would be called the dividend. Okay, dividend. That's what you're dividing into. The number after the main division symbol, this is called the divisor. Right, what you're dividing by. And what the final result is. Okay, so what this is equal to when you're all done is called the quotient. All right. Alright, and then just one other thing about division that I want to point out, one other note I want to make for you, is that division is the same operation, or is equivalent to multiplication by the reciprocal of the divisor. So you can take any division problem you are given, multiplication by the reciprocal of the divisor. So yeah, you can take any division problem you are given and change it into a multiplication problem. So what you're going to see in this video is that all of our division problems, when I'm asked to divide two fractions, two rational expressions, I'm going to change them into a multiplication of two rational expressions, and then we're going to treat it just as though we did multiplication in the last video I put up. All right. So for example here with the numbers off to the side, this 2/3, so this 2/3 divided by 7/9, the dividend doesn't change. Right? So the first fraction, 2/3, the dividend does not change. It's the division, the main division. When I'm dividing by this divisor, dividing by 7/9, that is equivalent to multiplying by 9/7. Remember the reciprocal is simply, flip the fraction around, make the numerator the denominator and the denominator the numerator. So 9 goes in the numerator, 7 goes in the denominator. So the reciprocal of 7/9 is 9/7. All right, and then I would just do plain old multiplication of fractions like usual. Multiply the numerators, 2 times 9 is 18, divided by, and then multiply the denominators, 3 times 7 is 21. And you may have already seen that both of these have a common factor of 3. Right, 18 is 3 times 6, 21 is 3 times 7, and you divide out the 3, and you're left with 6/7. Right, and then this 6/7 we would be calling the quotient, the result of the division, of the dividend by the divisor. All right, and in general, our division will look like this of two fractions. So say I have two fractions. I'll get back to that example in a second. So if I have a over b, right, one fraction, one rational expression, divided by, and then c over d, another rational expression. One thing I'm going to point out right away is, remember, denominators of fractions can't be 0. So before I even do the multiply by reciprocal thing of the divisor, I notice this denominator is b, and then this fraction has a denominator of d. So the b and the d cannot be 0. Right? So this is b or d, b and d can't be 0. And then I flip, okay, say this is equivalent to a over b, right? Again, you keep the first fraction, keep the dividend the way it is. And then when you see division, you can rewrite it as multiplication by the reciprocal of the divisor. So times, and then d over c. But look at what happens here. When you flip this fraction, when you change c over d to d over c, now there's a new number in a denominator, right? Before, d was in the denominator of this fraction. Now c is in the denominator of this fraction. So not only can b and d not be 0, but c cannot be 0 as well. Okay, so when you're dividing two fractions, the only part of the division that can be 0 is the numerator of the dividend, the a. b can't be 0, d can't be 0, c can't be 0, because really you're technically dividing by 0 if you have c equals 0, right? And you can't do that. Okay, so let's put this in a box here. Alright, so back to my problem, where I'm asked to divide these two fractions, find the quotient. 12, so I have one fraction, 12 over x squared minus x, divided by, and then another fraction, 4x minus 2, divided by x squared minus 1. Alright, so the first thing I'm going to do is factor everything, just like with multiplication of fractions. The first thing I'm going to do is factor each denominator and numerator completely. And that way we can very easily see what's not allowed to be plugged in for x. What gives me denominators of 0, which are not good. So factor each numerator and denominator completely. So here, now if you'd like, I'm going to factor, even numbers down to their prime factors. 12, when you factor 12 completely, is 2 times 2 times 3, or 2 squared times 3 if you like. Right, that's 12 over, and then x squared minus x, they have a common factor of x. Pull that out, and then what's left over would be x minus 1. And still a division problem. I'm going to get to this where we rewrite it as a multiplication problem in a second. Then this 4x minus 2, this numerator, greatest common factor of 2. Alright, so I'll pull the 2 out. and then what's left over there would be 2x minus 1 as a factor, and then all of this divided by, and then x squared minus 1, this denominator, this is a difference of two squares, right? X squared minus 1 squared. So that would factor to x plus 1 times x minus 1, or x minus 1 times x plus 1, whatever order you like. Okay, so every single numerator and denominator is broken down completely, factor completely. And now I'm going to do this off to the side. I'm going to point out some values I can't plug in for x. Right? Remember this guy here, right? This denominator can't be 0. This denominator can't be 0. And we'll even see after flipping it, right? After flipping this fraction to write it as a multiplication problem, this can't be 0 either, this numerator. The only thing that can be 0 is the numerator of the dividend, but it's 12, so it's never going to be 0. But for right now, I'm going to point off to myself that the value I replace x with can't be 0, right? For this factor, that'll make this denominator 0. X can't be 1, right? Because that would make this factor 0, making this denominator 0. Same thing here, can't be 1 over here either, right? It'll make this denominator 0. And also, looking at this factor of this denominator, can't be negative 1. Alright, so right now that's my list of, it'll be added to, you'll see. But for right now, these are the values of x I cannot replace, values I cannot replace x with. Alright, because I'll be having denominators that are 0, right? Dividing by 0. Alright, so then after factoring everything completely, alright, I'm going to then rewrite as a multiplication problem. Alright, we're going to multiply by the reciprocal of the divisor, right? This would be called the dividend, and this fraction's the divisor, remember. Okay. Multiply by reciprocal of divisor. Alright, so this this expression here is equivalent to, again, my first fraction, my dividend does not move. It stays the way it was. So there's your 12, 2 times 2 times 3, over x times x minus 1. And then here comes the change, right? We're changing a division problem to a multiplication problem. So times, and then, flip this fraction. Right, so now this becomes the denominator, this becomes the numerator. So my numerator is now x plus 1 times x minus 1, and then the denominator is 2 times 2x minus 1. Alright, so now I'm going to add one more number to the list of numbers we cannot use. Alright, so back up here. X can't be 0 because of this factor, can't be 1, can't be negative 1. And then when I flip this fraction, you see now I have a new denominator in this this side, this second fraction. And 2 is never going to be 0, this factor, but this factor, 2x minus 1, that'll be equal to 0 when x is 1/2. Right, you would add 1 divided by 2 if you set that equal to 0. So 1/2 is going to be added here to the values that I cannot replace x with. Right, if I replace x with any of these four numbers, I'm going to be dividing by 0 at some point during this problem, and that's no good. All right, then after this, just continue on back to the page we had earlier. All right, then after the multiply by the reciprocal, then we do the multiply the fractions and simplify. And we have seen, I've put up a video on this previously. Now the problem is no different than what we saw in my last video. Again, you can look that up, or look up other videos, or read something from your text on multiplying rational expressions. But just multiply the fractions, and I'll just add this to the same step, and simplify, meaning divide out any common factors that the numerator and denominator have. Alright, so this fraction times this fraction. Again, you just multiply the numerators, and all I'm really doing is listing the factors. We have a factor of 2 times another factor of 2 times 3 times x plus 1 times x minus 1. All those are the factors of the numerator. That's what you get when you multiply the numerators. And I do the same for the denominator. Right? The denominators, I multiply these factors by these factors, and again I like to put the numerical ones first, so I have a factor of 2, and you can rearrange them however you like, right? You rearrange factors and still get the same product. So I have a factor of 2, then times, a factor of x, and then I have a factor of x minus 1, and a factor of 2x minus 1. Okay, all those are factors of the denominator. And again, keep in mind, x cannot be any of these four numbers. Alright, and then we're going to cancel or divide out some common factors in the numerator and denominator. So I'm noticing both have a common factor of 2, right? So 2 divided by 2, those technically become 1, right? Anything divided by itself is 1. They don't just disappear, but then you have times 1, and that's not really doing anything. Then the only other common factor I'm seeing are the x minus 1s, right? There's x minus 1 there, x minus 1 there. And that seems to be it. So now we simplify and write down what factors are remaining, right? So that's equal to, 2 times 3 is 6 now. I'm going to simplify, actually multiply that out, 6. And then we have the other factor of x plus 1 still, so 6 times the quantity x plus 1 in the numerator. And then in the denominator, that's 1, that's 1. So I'm left with the factors of x and 2x minus 1. So x times 2x minus 1. Right, and then off to the side, again, I'm going to put down those values of x I couldn't use, right, back up here. X cannot be replaced by the number 0, the number 1, the number -1, or the number 1/2. And there we go. Now if you would like to multiply those out, you can. You could also distributed the 6 here and said the numerator was 6x plus 6, and then distributed the x and said the denominator was 2x squared minus x, and with these restrictions, that'd be fine as well. But there's nothing wrong with this. This is considered, simplified for a fraction. There's no common factors in the numerator or denominator. Alright, and then if you would like to test this, alright, just a couple times, if what you say is true, if this fraction divided by this fraction truly is equal to this fraction here, well then they should have the same value no matter what I plug in for x, as long as it's not one of these four, right? Plug in anything but 0, 1, -1, or 1/2. So let me test that out. Let me test with how about when x equals 2? And again, you can do anything as long as it's not these four. So I could try 2, try 3, try 5, try -8, try 1/5, a billion, whatever you want. And this division should be equal to this number here. Alright, so let's look at up here. Alright, when x is 2, this fraction would be 12 divided by, and then 2 squared minus 2. That'd be 4 minus 2. That's 2. Alright, so that's 6. And then we have divided by, and then this fraction, the numerator, when x is 2, would be 4 times 2, which is 8, minus 2 is 6, divided by, and then 2 squared minus 1, that's 4 minus 1, that's 3. So what I'd have here is, 12 divided by 2 is 6, divided by, and then 6 divided by 3 is 2, and then 6 divided by 2 is 3, a nice whole number 3 here. Now let's see if I get that with this, that's what I get when x is 2 back in the original expression. Try it out in my new expression, what I said it was equal to. So in this guy, in the numerator, we'd have 6 times, and then 2 plus 1. So 6 times 3, that'll be 18 in the numerator. And then the denominator, I have 2 for x, right? 2 times and then 2 times 2 minus 1 would be 4 minus 1, that'd be 3 again. And can you see how the 3's are canceling? 6 divided by 2 is 3, and they are the same value. This division, this expression up here has the same value as this one when x is 2. And if they truly are equal, that should be the case. They won't always be 3, but they'll be the same number no matter what you plug in. All right, plug in 5, plug in a billion, like I said earlier. Plug in anything you want except these 4. Right? If you plug in these 4, you're going to get undefined. You're going to be dividing by 0 up here, and that's no good. All right. Okay. So I was a little long-winded that one because of all the checking and whatnot and explaining, but let's move through some more examples of dividing fractions here in a bit. All right. So here's another one. So I've got a fraction, x squared minus 9 divided by x squared minus 16, and then that divided by, and this is the main division, right? I know I remember in the previous video I've mentioned whenever you see a fraction bar, that is also division. So technically I could write this way if I wanted, where I'm doing this, I have x squared minus, in parentheses, the quantity x squared minus 9, that's the numerator of this fraction, then divided by, and then x squared minus 16, and then close parentheses, because all of that is the, this entire thing is the dividend, right? The thing before the main division. And then we had division again, right? The main division. And then in parentheses, I'll put this whole fraction here. This whole thing is the divisor. And then, the numerator of that divisor is x squared minus x minus 12. And divided by, fraction divided by, and then x squared plus x minus 12. And then close the parentheses. That whole thing is the divisor. So, I mean, I could write it out like this if I wished. Just you can see probably why they don't do that, because it is pretty cluttered, lots of parentheses, lots of division signs here. But this is the main division. I'll call it the main division right here in the middle, right? This guy right here, separating my dividend from my divisor. Another way this could be written, I just want to point this out too. The way I wrote it here, I changed all the fraction bars to division signs, because that's what a fraction is, it's division. But I could also change this division sign to a fraction bar and make it what's called a complex fraction. So I could also change this to, my divisor first, or I'm sorry, my dividend first. I write the dividend, x squared minus 9 divided by x squared minus 16. There's all that's the dividend. And then this division sign here, change it into a fraction bar. But again, that's the main division. And you'll see in most textbooks, it's either going to be the longest fraction bar or it's in bold. Right? It's either the longest bar or it's in bold face, like really thick, make it thicker in a textbook. And then in the denominator, my divisor, right, below the main division, the divisor, this fraction here, the x squared minus x minus 12, divided by, sorry, that should be bigger, divided by, and then x squared plus x minus 12. And so you could write this way as well. All three of these mean the same thing. Okay, they all represent the same problem. So it can be a bit tricky sometimes, but just remember that you can go back and forth. A division symbol can be written as a fraction bar, or fraction bars can be written as division symbols. Right? They mean the same thing. All right, so I'm going to stick to the way it originally looked. All right, we'll just kind of block this stuff off. I'll stick to the way it originally looks and go through the procedure I described to you in the last example. Alright, so the first thing I'm going to do is factor everything. Factor the numerators and denominators of both fractions. So x squared minus 9, difference of squares, that would factor to x plus 3 times x minus 3. Then the denominator, x squared minus 16, another difference of two squares, that would factor to x plus 4 times x minus 4. Alright, then we have divided by, and then this fraction, the numerator is a quadratic with a lead coefficient of 1, so very simply, again, I'm just going to kind of rush this. You can look for other videos on factoring quadratics and factoring polynomials, please. This would factor to x minus 4 times x plus 3, and you can double check that by multiplying these FOIL, and you should get that back. Over, and then x squared plus x minus 12, that would factor to x plus 4 times x minus 3. Right. Okay, and then here comes the, so now I've factored everything. And once I've factored everything, again, I do like to point out to myself some values that the variable cannot take. So remember, denominators can't be 0. Right, so here I have these two denominators with these factors. This factor x plus 4 is in a denominator, so x can't be negative 4. Right, that'll make that 0. I have a factor of x minus 4 in a denominator, so x can't be positive 4 either. And then I already did x plus 4, and then in this denominator, I have another factor of x minus 3. So x can't be these numbers right now. And then when we flip, we'll also see that x can't be negative 3, right? Because of this x plus 3 factor will go in the denominator once I multiply by the reciprocal. But I'll add that in a second. But so I can plug in anything I want for x, except these three numbers right now. And then here comes the part where I change the division problem to a multiplication. So we have x plus 3 times x minus 3 over x plus 4 times x minus 4, and then change division. Anytime you see division, it's just multiplication by the reciprocal, so of the divisor. So I times and the reciprocal of the divisor. So we have x plus 4 times x minus 3, right? This denominator became the numerator, and then divided by, and then x minus 4 times x plus 3. And then so one more thing I'm going to point out is that now I have x plus 3 in a denominator, so x can't be negative 3 either. Right? So x cannot be replaced with any of these four numbers. Okay, then doing the multiplication. So I just list, basically listing the factors. We have x plus 3 times x minus 3 times x plus 4 times x minus 3 in the numerator. And then multiply the denominators, and you have the factors of x plus 4, x minus 4, x minus 4 again. And again, if you want, you can write x minus 4 squared, and then here, x minus 3 squared, because you have two of them. And then another x, and then x plus 3 down here. And then we're going to cancel any common factors. So I'm noticing the numerator and denominator have a common factor of x plus 3. So those become 1, right? Again, technically they become 1. I'm also seeing x plus 4, right? And that looks like about it, right? So when all is said and done here, I've got x minus 3 times x minus 3. Now here is at the end is where I'll write this, x minus 3 squared, right? That's what it means to have x minus 3 times x minus 3, right? X minus 3 to the second power. And then the denominator, same thing. I've got two factors of x minus 4. So that's the quantity x minus 4, to the second power, x minus 4 squared. And then again, just make a note to myself that, this fraction divided by this fraction will be equal to this fraction always, except for when the value of x is these four numbers, right? X cannot be 4, negative 4, 3, or negative 3. Right. And again, double check, right? Try some other numbers out. Just make sure you're not plugging in negative 4, 3, or negative 3. But try, when x is 0, this would be 9/16 basically, divided by 1. So that'd be 9/16. And when x is 0 down here, you get negative 3 squared is 9, positive 9, negative 4 squared is positive 16. You get 9/16 down here. So this division is the same as this fraction when x is 0. And try it with 1, 2, 5, a million, a billion, a third, negative 8, whatever you want, as long as it's not one of these numbers. Great. So here's yet another example. Now this one might be a little trickier because you might think, hey, so there's the main division, looks like, right? So this fraction is the dividend, and then this quantity, this q minus 7, is the divisor. And you might be thinking, well, hey, I thought you said, this was all about dividing fractions. That's a fraction, but, that's not a fraction. There's no denominator. Well, technically there is. Right? Whenever you have a whole, something without a denominator, for example, say the number 3, you can always divide something by 1, right? Dividing by 1 doesn't change the value of your number. So whenever something doesn't have a denominator, you can always put a denominator of 1 under it. So I'm going to do that here. So it was originally just q minus 7. Now it's q minus 7 divided by 1. So I have the look that I want, fraction divided by fraction. Okay, so the same procedure goes. I'm going to factor everything. The numerator of this fraction, q squared minus 6q minus 7, that would factor to q minus 7 times q plus 1 over, and then q squared minus 25 is another difference of squares, q squared minus 5 squared, that would factor to q plus 5 times q minus 5. Alright, and then we have divided by, and then q minus 7 doesn't factor, and so that's the only factor. So I'm going to keep it in parentheses to indicate that that whole thing is still the only factor in the numerator. And same with the denominator. 1 is just 1. 1 doesn't factor any further. Then off to the side, and I'm going to put some values that q cannot be replaced with. Alright, so q cannot be equal to, and look at my denominators, right? These two factors, q plus 5, q minus 5, are in the denominators. So q can't be negative 5 because of the q plus 5, and it can't be positive 5 either, right, because of the q minus 5. And then the other denominator here is 1, which is never going to be 0. It's always 1, so you're fine. But I'm going to flip this in a second, so we'll see that also, q minus 7 can't be 0. So I'm going to do that right now. I'm just going to say q can't be 7. Right, because in a second this q minus 7 is going to go in the denominator. Right, so here comes the part where I rewrite it as a multiplication problem. So we got the q minus 7 times q plus 1 over, and then q plus 5 times q minus 5, and then every division problem you can rewrite it as a multiplication problem, where you multiply by the reciprocal of the divisor. So the reciprocal of this would simply be 1 divided by q minus 7. And you can see that now, q can't be 7. Right? You're dividing by 0. Alright, and then multiplying the numerators, it's just simply q minus 7 times q plus 1, times 1. But there's really no reason to write times 1, because that doesn't do anything. Get the same value. And then the denominator has the factors q plus 5 times q minus 5 times q minus 7. Alright, and then common factors here, really only seeing the 1, q minus 7, q minus 7. Alright, so when all's said and done, I've got q plus 1 in the numerator over, and again, since it's the only factor, you can put parentheses around it, but it's really not necessary. It's the only factor. So I'm going to q plus 1, no parentheses, divided by, and then in the denominator I have factors of q plus 5 and q minus 5. And again, you can leave it like this or make this into q squared minus 25. It doesn't matter, right? But it is simplified. There are no factors now common to the numerator and denominator. And again, this division I started with is only equal to this fraction here as long as the value of q is not one of these three numbers, right? So I'm going to again write that off to the side here. As long as q is not -5, +5, or 7, we're good. These will be equal. All right, this division here and this fraction here. And again, you can test it out. You know, if again, an easy one would be if q is 0, right? If q is 0, this should be 7/25, -7 divided by -25, that'd be +7/25 divided by, and then just, you know, -7 if q were 0, and 7/25 divided by -7 would be just 1/25, you know, after multiplying by 1/7, right? You do the multiply, so 1/25. And then here if q is 0, I'm sorry, -1/25, right? It would be 7/25 divided by -7, so positive divided by negative would be negative. You have -1/25. And if q is 0 down here, you'd have 1 in the numerator, and then 5 times -5, you know, 1 over -25, -1/25. They are equal when q is 0. And try it out with other numbers, right? These should be equal for any value you replace q with, again, as long as it's not one of these three, because you'll be dividing by 0, you know, in the problem. All right, so another one. So here I have, again, I mentioned this earlier, fraction divided by fraction, where, you know, the large bar, and again, in most texts it's either the larger bar or the one in the middle or the thicker one, but this one is our main division bar right here. So everything above it would be the dividend in my problem, and everything below it would be the divisor. Right? And if you'd like, you could rewrite this in the way we've been seeing, where my dividend is, you know, 2 over x plus 1, and then I can replace this main division bar with, you know, the division symbol, and, you know, rewrite it like my previous examples. And then the divisor is this 8 over x squared minus 1. And that's fine too, right? They mean the same thing. You could go back and forth between these. All right, so I'm just going to I'm going to do this. I'm going to write it this way, because I'm used to this now, right? We got several examples now of that. So I'm going to factor everything, right? This is 2 over, you know, x plus 1, and that's the only factor down there. Again, I'll put parentheses around it for right now. And then divided by, and then, you know, this is 2 times 2 times 2 when you factor it completely, 8, or 2 cubed, 2 to the third power, divided by x plus 1 times x minus 1. And I'm going to rewrite it as a multiplication problem, right? 2 over x plus 1 times, and then x plus 1 times x minus 1 divided by 2 times 2 times 2. Oops, and I forgot to state the values that x cannot be. All right, so as I work through this problem, I notice that x can't be -1 or +1, right? Because that'll make me divide by 0, have denominators of 0. When I flip it over, right, the denominator of this fraction is just 8. That's never going to be 0, so I'm not adding to this list of numbers I can't plug in. All right, and then hopefully you can see the common factors. I mean, if you put them together, that's 2 times x plus 1 times x minus 1 in the numerator. And then we've got 2 times 2 times 2 times x plus 1 are the factors in the denominator. Cancel common factors. The x plus 1s and one of the 2's go away. And then when all is said and done, we finally have x minus 1 left over in the numerator. And again, since it's the only factor left and I'm done simplifying, I don't need parentheses around it. all that over, and then 2 times 2 is 4, and that's it. So x minus 1 divided by 4. I probably should have put this more centralized. So this division right here will be equal to this fraction here as long as x is not 1 or negative 1. And again, try it out, plug in some other numbers, plug in numbers other than these, and you'll see that that division is indeed equal to this here. Alright, so I've got a couple more real quick ones. Again, I'm just doing the same stuff. Now I'm going to even skip one of these steps here. Hopefully by now you see that I'm doing this multiplication by the reciprocal deal. Alright, so here I have one where we have again, this is our main division bar here, the longest one or the thickest one or the one in the middle. So I'm going to rewrite this using the division symbol. This is x, just to get it be familiar, and get it to be similar to the previous examples. So there's my dividend, and then we're dividing it by, and then the divisor is 4 times x plus 12 over 7x squared plus 14x. Right, there's the divisor. I'm going to factor everything. This is x plus 3, and that's the only factor of that, over, and then x squared minus 4 would factor to x plus 2 times x minus 2, and then divided by, and then this factors to, I could pull a 4 out, which is 2 times 2. Right, that's the greatest common factor is 4, and 4 breaks down to 2 times 2 times, and then 4 times x plus 3 would be left there. And then greatest common factor down here is 7 times x, right? So I pull out 7 and an x, right? Those two factors, 7 and x, and then what's left over would be x plus 2. Right, so I'm going to again point off to myself some values I couldn't plug x in this expression. I couldn't plug in 2 or negative 2 because of these factors. Couldn't plug in 0 because of the factor of just x there. And also we have a division problem here, so we're going to be flipping this. This x plus 3 will go in the denominator, so I can also not use negative 3, right? That'll make that factor 0, so I'm going to write that right now. Alright, so now here's the part that I'm going to skip. I'm going to skip writing the multiplication. I know I'm going to rewrite this as times the reciprocal of this fraction, so I'm just going to write the end result, where this fraction, these factors and this factor, right? These factors and this factor would be in the numerator after multiplying. So 7 times x plus 2, and then times x plus 3 would all be in the numerator. And then these factors would go in the denominator with these factors. Right? So then I have 2 times 2 times x plus 3. Right? Those factors times x plus 2 times x minus 2. Those would all be in the denominator when I multiply. And then we cancel common factors. I'm seeing x plus 2, x plus 2, x plus 3, x plus 3. Right? Those all become 1. And that's it. Right? So what I'm left with is 7 times x in the numerator divided by, and then 2 times 2 is just 4, times this quantity x minus 2 in the denominator. And again, if you'd like, you can make that 4x minus 8, but this fraction is considered simplified because there are no common factors in the numerator and denominator. And again, the only way this crazy expression up here will actually be equal to this is when x is not these numbers, right? 2, negative 2, 0, or 3. All right, but for anything else, plug in anything else you want, and this fraction here will be equal to this crazy division up here. And you can check it out. Try 1, try 5, try negative 8, negative 10, whatever you want. All right, and then I have one last example where there are 2 variables. Right? We haven't seen an example where there's multiple variables, but the procedure doesn't change. Okay, the procedure does not change at all. So got it written the way we're used to, right? So here's the dividend fraction, here's the divisor. I'm going to factor everything, right? So the greatest common factor of 3m minus 6n, right? No, 2 variables now, m and n, is 3. Right? So I pull 3 out, and then there'd be m minus 2n left over 5 times n. None of those break down any further. 5 is prime and n is just n. And then divided by, and then this is a difference of squares. This is m squared minus, and then this is 2n times 2n, right? Would be 4n squared. So m squared minus the quantity 2n squared. So that'll factor to m plus 2n times m minus 2n, right? Like you factor a difference of squares in the binomial conjugates, right? And then 10mn, well 10 breaks down to 2 times 5, and then you have times m times n, right? Okay, so now that everything's factored completely, again I'm going to, off to the side here, I'm going to write down some numbers that we can't use for the variables. There's a factor of just n, right? So n can't be 0, right? That'll make that denominator 0. Same thing here, there's a factor of just n. So n can't be 0. Same thing in this denominator, there's a factor of just m. So m can't be 0 either, right? Because that would make that denominator 0. And then these two, right? I'm going to be flipping this, so I'm going to be multiplying by the reciprocal. So these two can't be 0. So m plus 2n can't be 0, meaning that m cannot be equal to the opposite of 2n, right? If you subtract 2n. And the m minus 2n, this factor, can't be 0 as well. So again, adding 2n if you want, m cannot be twice n. So all this means is that if I let n be 2, m can't be negative 4, right? M can't be negative 2 times my choice for n. If I let n be 5, I can't replace m with negative 10. And the same thing here. This just means m can't be twice what n is. So if I let n be 3, if I replace n with 3, m can't be 6. If I replace n with 7, m can't be 14, because I'd have zeros here and here, in one of these places, which would eventually be just dividing by 0, and that's no good. Alright, so I'll get to that in a minute. Alright, so now I'm going to rewrite things where, again, I'm going to kind of skip the rewriting as multiplication step. This is times and the reciprocal of the divisor. So these factors will go in the numerator with these factors. So I'll have 2 as a factor, 3 as a factor, 5 as a factor, and then m, n, and m minus 2n, all in the numerator when I change it into a multiplication problem. Alright, so again, these factors with these factors. And then these factors will go in the denominator with the 5 and the n. So I'll have 5 times n, and then times m plus 2n times m minus 2n in the denominator after I rewrite it as a multiplication problem. And then we cancel any common factors. Seeing factors of 5, n, right? They both have n to the first, and they both have this m minus 2n factor, and that looks like about it. So when all's said and done here, we get what? 2 times 3, so 6 times m, and that's it in the numerator, divided by, and then the only thing left in the denominator is the m plus 2n, and again, since it's the only factor left, I'm not going to put parentheses around it. And there, I'm done simplifying the fraction. So this division, right, again, this division will only be equal to this fraction here as long as n is not 0, m is not 0, m is not equal to the negative 2 times n, and as long as m is not equal to 2 times n. Right? All these restrictions I put up over here. Okay, and let's actually test this one. Alright, just with one off to the side here. I can't spell. I'm actually going to test it. So I'm going to choose a value for m and a value for n, and we're going to check them. Alright. Now again, neither of these can be 0. And let's say I chose 1 for n. Now if I choose 1 for n, remember what these restrictions are saying is if I choose 1 for n, m can't be negative 2. And I'll be dividing by 0 here. And if I choose 1 for n, m can't be positive 2 either, because I'll be dividing by 0 here. Right? I'll have 0 in the denominator somewhere in this problem. So I can't use negative 2 or 2. I'll just use 1 again. Right? This is a possible choice for m and n. And again, there's infinitely many you can do. I can do, let's say n is 10 and m is 55. N is 3 and m is negative 7. Right? You can do anything you want as long as these things aren't happening. All right, so let's see what happens. If m is 1 and n is 1, well, let's see, 3 times 1 minus 6 times 1, that'd be negative 3. 3 minus 6 divided by, and then 5 times 1 is 5. And then I have divided by, and then 1 minus 4, so negative 3 again, divided by, and then 10 times 1 times 1, or 10. And can you see how if I flip this, right, this would be technically, again, times 10 over negative 3. The negative 3's would cancel. I'd be left with 10 over 5. This is 2. 10 divided by 10. This is 2. All right. All right. Now that's when I plug those in here in the original. What if I plug in 1 and 1 here? So I'd have 6 times 1, or 6 in the numerator. Right. 6 times 1 divided by, and 1 plus 2. Right. 1 plus 2 times 1 divided by 3 is, yes, 2. 6 divided by 3 is 2. They're the same thing when m is 1 and n is 1, and they should be the same value. If they truly are equal, they'll have the same value no matter what you plug in for m and n, as long as you don't plug in 0 for m or 0 for n, or and again, m is not negative 2 times n and m is not 2 times n. Right? As long as these things aren't happening, you can plug those in and check them out and see that, yes, indeed, this division is equal to this fraction. All right, so that was a lot of examples today. As always, I like to say, please read the material, try to get things on your own first, read through the author's examples, try to work out things on your own. I feel like it sticks better when you manage to get things on your own, and don't just give up after the first attempt of a problem or first attempt of a section. Try it multiple times, and if after several attempts it's still not clicking, maybe read through the section again. Maybe something will click the second or third time around that didn't click the first time. But if after that you've exhausted yourself, it is not a sign of weakness at all to go out looking for help. All right, to go asking a teacher, asking a tutor, asking a friend who knows the material, looking for videos on the material such as this one, or ones that are better out there. There's plenty of them, I assure you. And just keep at it, stay persistent, and I know you can get it. I believe you can get it, and also try to have fun with it too. Don't bore yourself to death. All right, thank you.